So I'm going to go over some topics from Chapter 7, Object-Oriented Design. So the things that we're going to cover is relationships between classes. We're going to talk about writing interfaces. We're going to talk about designing enumerated types. We're going to go over the iterator interface and the array list. Those are both from Chapter 5. Class relationships. The book talks about 3 different relationships between classes. One is dependency. That's when a class uses another class. Aggregation. That's when a class has another class. And inheritance. That's when a class is another class. So it's important to note that inheritance is something that we're going to talk about in Chapter 9. So we'll go in more detail on that topic in Chapter 9. A dependency exists when one class relies on another in some way, usually by invoking methods of the other. We've seen dependencies in many previous examples. We don't want numerous or complex dependencies among classes, nor do we want complex classes that don't depend on others. A good design strikes the right balance. Some dependency occurs between objects of the same class. A method of that class may accept an object of the same class as a parameter. For example, the concat method of the string class takes a string object as a parameter to a method. The following example defines a class called rational number. A rational number is a value that can be represented as the ratio of 2 integers. Several methods of the rational number class accept another rational number object as a parameter. See rational tester and rational number. So here's the rational tester class. So these are actually in the slides, but I went ahead and put these examples into Dropbox. So if you go to the Dropbox folder I shared with you, I added a new folder called book content. Click on that, then go under examples, then go to Chapter 7 examples, then go to the rational tester project. Inside the source folder, you'll find rational number and rational tester. You can open these files and examine them in more detail, but I'm going to use what we have inside of the PowerPoint. The rational tester class is a driver class that's instantiating several rational number objects. So I'm just going to go straight to the rational number object. So here is the rational number class. Here is the rational number class. So you can poke around it and look at all the details. If you go down to the subtract method and the multiply method, you can see it's doing the math and returning a rational number. This is what we call dependency. So it's depending on itself in order to make these methods actually work. Another example of dependency is the die class that I created. So the die class actually relies on the math class to do its random number generation. So this is an example of dependency because it's relying on the math class in order to generate this random number. Now, if I were to change this to use the random class to generate the random number, then this die class is dependent on the random class to do the random number generation. The relationship between the die and the math is the die uses the math class. Now the pair of dice actually has 2 die objects, right? So this is what we call aggregation because the pair of dice has 2 die objects associated with it. So when we look at this, because the pair of dice has these 2 objects as instance data, this is what we call aggregation. An aggregate is an object that is made up of other objects. Therefore, aggregation is the has a relationship. A car has a chassis. An aggregated object contains references to other objects as instance data. This is a special kind of dependency. The aggregate relies on the objects that compose it. So the pair of dice class is dependent on the die class, but since it has it as instance data, it's actually an aggregate relationship because it has die objects. So aggregation is a special kind of dependency. Whereas in the die class, in order to roll, the die class depended on the math class for its random number generation. That's dependency. Aggregation is when you have an instance of that object as part of that object. In the following example, a student object is composed in part of address objects. A student has an address. In fact, each student has 2 addresses. So here they give you some classes that the book created. You have student body, which is a driver class. It's instantiating address objects and student objects. You have the address class, which is composed of a street address, city, state, and a zip code. And you have the student class, which is composed of a first name, last name, and has 2 addresses, a home address and a school address. So this is what we call aggregation because the student class has addresses. So it's relying on the address class in order to provide those addresses. So here's the UML diagram for the book's example. Here's the student class. The student class uses the address class, so it's linking in this address class. And that covers dependency and aggregation. The next relationship is inheritance, and we'll cover that in Chapter 9.